So next in the speaker lineup, and I've got my little sheet here, we have Alina, and Alina also is one of the people that I find incredibly threatening with the incredible talk that you did there. And you've just branched off with Graal and Quarkus, and Alina really is well, she is Graal. She is Mrs. Graal. So yeah, so Alina, Mark just gave you a great introduction around Graal, and you've got an incredible talk that I'm going to drop off. Mark and I are going to drop off, and you're going to start with that incredible talk around how to actually use Graal, the new improvements that you've done, the new native images that you've done there. You've just launched 22.1, and over to you, Alina.
Hi, good morning, and thank you, Mark, for doing a great intro to my session. I tweeted already, so thank you for that. And yeah, I think we're good to go, right? You can see me, you can hear me, I can start sharing, right? Okay, I think we are good. So hi again, everyone, and good morning from sunny Stockholm. My name is Alina Renko, and I'm a developer advocate for GraalVM at Oracle Labs. And let me just get my slides so we can get going. We can in 30 minutes, and that's going to be a challenge, but let's hope that I can give at least you and solve it over you. So first thing about GraalVM, what it is and what it does, it's a high-performance virtual machine, and it can run all those languages that we see on top here and also work in a number of environments that we see below. So it can obviously run Java and JVM languages, such as, for example, Scala, but not just that. So we also have implementations for languages like JavaScript, Ruby, R, and Python, and all of them can run on GraalVM with high performance. And the best part is that they can also interoperate between each other, still with high performance on GraalVM because it supports all of them. And what's also interesting about GraalVM is that it's highly embeddable. So you might have heard about the context of OpenJDK, in which we can run your normal unmodified Java applications in JIT mode. But what's interesting is that GraalVM can also work in context of environments such as Node.js, where we run unmodified Node.js application, or even be embedded in a database to execute those languages that we see on top here, right in database. And last but not least, GraalVM also has this standalone mode, so native image mode, where GraalVM is the only runtime that we would need to execute your applications. But we will get to that in a second. So what GraalVM offers for us, and more specifically, what does GraalVM offer for Java developers? So there are a few things. First thing is that you can get more performance with GraalVM in a JIT mode. So that is your normal way of executing applications on a JDK, where you have basically a normal JDK just with a different, highly optimizing Graal compiler. That is one thing we will talk about in detail in a second. Now, another thing, and a very interesting and exciting one, and that is something that Mark mentioned in his keynote, so thanks to him to that, is the native image mode. So that is this ahead-of-time compilation mode, where you can take your application, compile it ahead of time into a native executable, and get those amazing benefits of fast startup time and low memory consumption. And last but not least, it's also a Polyglot VM, so all those languages you've seen on the previous slides can easily interact with each other on GraalVM as a platform. And to give you an idea of how it all works and how it looks under the hood, so this is a high-level overview of the GraalVM architecture. So what's interesting, what you see here below is, as the base runtime that we use for executing applications, we have just the normal Java hotspot VM that we all know and love. So under the hood, there is a Java hotspot VM. But what is different about it is that we plugged in this brand new, highly optimizing GraalVM compiler that has quite a few new additional performance optimizations. And this is where you can get this additional performance benefits from when you are running on GraalVM as a JDK. So this kind of base layer is how we execute Java and JVM languages in JIT mode. But you see that there is another layer on top as well. That is our language implementation framework. And that is the way how we execute and implement previously all those languages such as JavaScript, Python, Ruby, and so on. So this is basically how GraalVM looks from the inside. And if you would like to get even better idea of how it works and what it looks like from the inside, GraalVM is also a big open source project. So our main repo is on GitHub, and if you're curious about it, I encourage you to go and take a look. In fact, if you're a Java developer, it should be quite interesting and fairly accessible to you because our development is happening in Java. So if you're a Java developer, you can easily understand what is going on there, relate to it, maybe learn some good practices for it. It's a great project and interesting to follow. So go to GitHub and give it a like, follow it. It's really interesting to follow. Now, let's talk a bit more detail about how GraalVM can execute Java. So there is this important distinction that I want to make, that there are a few ways how you can run Java on GraalVM. So you can run Java on GraalVM in JIT mode as on a JDK, as you, for example, maybe run your applications on OpenJDK or any other JDK, and that is still possible on GraalVM. So you can just run your applications with the Java command, how we see on the left here, and that works on GraalVM just as on any other JDK because we do have a full-blown JDK inside GraalVM. So that is one thing, and the reason why I stop here and I emphasize this is because the second mode, right, the native image mode, is so exciting that sometimes people associate GraalVM with it entirely. So basically when they say GraalVM, they mean native image. And it is fascinating and very helpful, right? The native image component of GraalVM. But that's not the only thing and not the only way to run Java on GraalVM. So I just want to make this important distinction, right? To say that with GraalVM, you get options, right? So you get to choose how you want to run your applications on GraalVM, and based on what you're trying to accomplish. So for example, what your performance goals are, you can choose either the JIT mode or the native image mode if you want to optimize for the best possible startup performance and resources usage. So yeah, a couple of ways to run Java on GraalVM are as we see here. And if I'm being entirely honest, like I don't want to confuse you, but in fact, as of some time ago, there is even one more way to run Java on GraalVM. So I will not stop here because this is not the topic of today's talk, but just to give you a full idea. So on previous slides, we've seen that there are all those languages implemented on GraalVM's language implementation framework, which is called Truffle. So languages like JavaScript or Python. And in fact, we also have a similar implementation of a JVM on GraalVM. So in fact, it could be running Java in a third way on GraalVM, and that is through this Java on Truffle project, which will give you another execution profile and even better interop with all those other Truffle languages. So this is not the focus of today's talk, but just to be fair, I wanted to mention that there are, in fact, 3 ways of how you can run Java on GraalVM. But let's take a closer look at the first 2. So why would you use them, how exactly, and when should you choose each? So GraalVM as a JDK, this first JIT execution mode. So in this mode, as I said, basically as the runtime, we have Java Hotspot VM. So you get all your favorite tools, all your favorite capabilities. The only thing that has changed, as we see on the chart below here, is through something called Jvmci, so JVM compiler interface. We plugged in this external compiler, the Graal compiler, and the rest basically stays the same. So you have a new highly optimizing compiler. The rest is your just normal JDK as you know it. So you can imagine migration is quite easy, right? Because it's your normal JDK, your normal way to run applications. So migration is as easy as just swapping your JDK distribution for GraalVM. And if you're curious, we have builds available for Java versions 11 and 17. So yeah, if you're on either of those, very easy for you to migrate to GraalVM. Go ahead, give it a try, and tell us how it works. So yeah, migration is very easy. You get to use all your favorite tools, and what you get after switching to GraalVM is higher performance in many, many scenarios for many workloads. And to illustrate the thought about higher performance, so I want to share some benchmark results with you. What we are looking at here is Renaissance benchmark suite, and that is comparing GraalVM's performance to the baseline, which is OpenJDK. And yeah, so OpenJDK are those yellow bars. Red, that is GraalVM Community Edition, which is our open source project. And the blue one, that is GraalVM Enterprise, which is a commercial version of GraalVM. So comparing to OpenJDK, you can see that, well, obviously each workload is different and performance numbers will be different, but you can see how for quite a few workloads you can get additional performance benefits with GraalVM. And if you're wondering what kind of performance benefits you can expect for your application with GraalVM, probably there is no universal answer because every application is different. It's written differently. It uses different dependencies. So the best way to figure it out would be to actually take some sample of your workload, run it on GraalVM, see how it works for you, see how much performance you get. So the easiest way to figure out expected performance is actually to try it on your own application. And yes, I encourage you to do so. Now let's talk about native image, right? So it's quite exciting and I want to dedicate quite a bit of time to it because I think you will like it a lot. So native image is this ahead-of-time compilation technology that allows you to take your Java application, compile it ahead of time, and produce this platform-specific native executable of your application. And the reason to do so would be that this application will start very fast and will use very little resources because it is optimized and compiled ahead of time, and it doesn't require a JVM to run, which is probably the most fascinating thing about it. So it's ready to be working as it is, right? Everything that has to be in the application for it to work is already compiled, is inside there. So it can start very, very fast because all that heavy lifting, all that expensive operations such as analysis, optimizing the code, compiling it, that all already happened at the image build time, so that when you run the application, it can start very fast every single time. And let's look exactly how it works. So this is what is happening behind the scenes when you run your native image build process. So when you're using command like native image and give it your application, what happens is that we will analyze your application starting from its main entry point, and we will look for all the reachable code and also run initializations to try and find all the code that is necessary for your application to execute, to perform what it's supposed to be performing. And then we will take only that necessary code, right? So we will eliminate everything else to make sure that your application is as small, as lightweight, and as efficient as possible. So we will eliminate all the unnecessary code and only put the code that is supposed to be there in this final executable, so that you get this very efficient image version of your application that is doing exactly what it's supposed to be doing, but doesn't have any overhead in it, doesn't have any extra facilities, such as, for example, the compiler and things like that inside it, because it's ready to use as it is. Now, another interesting thing that is happening during the image build process is something called heap snapshotting. So as we are building a native image version of your application, we are also running initializations, and we are pre-populating heap for you. So then again, you can start very fast every single time when you start executing your application, because it comes with pre-populated heap. So we basically take care of all these expensive operations and move them to the image build step. So at the image runtime, your application can start much faster. And the way to work with native image is fairly simple. So first step is where you build your native image application. So you can either produce a platform-specific native executable, or you can build a shared library. And then as a second step, you just run it as the native application. Okay, so let's say you're interested in native image, and how do you get started with it? So where do you go? What is your next step? So probably the easiest way to do so, if you want to get started with native image, is go to our GitHub repo with GraalVM demos, clone it, and there are quite a few examples of working with different components of GraalVM. So that's probably the easiest way if you just want to try some applications for yourself. If you would rather create something on your own, so your own application, there are a few ways to get started, but probably I would recommend going with one of those frameworks that work with native image, because that will give you a lot of features and a lot of support out of the box. So if you would rather create your own application, I recommend checking out one of those frameworks. And the first one I want to talk about is Micronaut. So Micronaut is a great framework for writing Java application. It works great for microservices and serverless, but also basically for any kind of Java application you can think of. And a great thing about it is that it's really well integrated with GraalVM native image since day one. So if you're interested in native image and running applications on native image as a platform, Micronaut has really great integrations for it. And if you want to get started, they have this great launch page where you can configure your application, or you can use their CLI utility, which is called Mn. And the interesting thing about this Mn utility is that I believe it's also a Java application compiled with GraalVM native image itself. So if you ever use the Micronaut CLI utility, you kind of have first-hand experience with native image already. And to show you some of those performance benefits I've been talking for past 5 minutes about, I have this comparison of a Micronaut, in fact, application that I have been running in a jet mode and in native image mode. And on the first part of the screen here, we see that we're running our application in 2 modes. And the application is basically a simple web server processing requests and responding to requests with the data from a list. And that's the same application. And when we run it in jet mode, we see that startup is something like 3.3 seconds. While then when we run the exact same application on native image, it starts in 170 milliseconds. So much faster. And I think you can tell how that is great for web services, right? Where you want as little work to be done while the web server is idle, right? And most of the resources or be used when actual requests arrive and need to be served. So if you want to be efficient, right, and focus on producing a valuable result and not care much about the overhead, then native image is a great deployment model for such applications. So that is startup, right? Just time it takes to start the application, but what about doing some valuable work? So what if you measured how much time it takes to actually serve first request? So do something helpful, right? And that is exactly what we are doing on the second part of the screen here. So we are measuring how much time it takes to process first request, and also how much CPU does it use, right? So what about resources usage? And we see that numbers are similar, right? So comparing to jet mode, native image is way more efficient. So not only it is faster, but also it's using way less CPU. And to illustrate that thought and look at it from a bit different angle, so here we are looking at the similar application. So it's again a Micronaut application, and we are measuring CPU usage and memory usage in the just-in-time compilation mode and in native image mode. And I think this comparison is a great, very visual overview of how native image is very resources efficient, because you see that when we are running in just-in-time compilation mode, there is quite a bit of work happening in the first few seconds. So those red spikes, that is CPU usage, right? And the blue horizontal line, that is memory usage. And you can see that CPU is quite busy for the first 3 seconds or so, because there is quite some work happening when you first run your application in jet mode, right? So classes have to be loaded, code needs to be parsed, interpreted, and compiled. And that is important for peak performance, but that takes quite some time and resources in the beginning. While native image is doing the exact same thing, right? It's the same application, but since everything has been optimized and compiled at the image build time, it's way more efficient when you run your application. Now, and especially if you're thinking or already deploying your applications to the cloud, you could be interested in how does this scale, right? So what if I want to scale my microservices horizontally? Where am I in terms of resources usage, and how does that look on native image compared to running on the JVM? And here I have an example for it. So if you want to horizontally scale your application, native image is very efficient in a way that it's a native application, right? So things like image heap and machine code can be shared across applications, and you can see how much more memory efficient you can be if you're running on native image. So the red bars here on the chart versus running on the JVM. Okay, I've been talking quite a bit about Micronaut and how it works with native image and what you can build with it. But in fact, there are many frameworks in the Java ecosystem that work well with native image. So in the keynote, Mark mentioned already Quarkus. So that is another great framework to work with native image. There is also Helidon. And another one that I want to talk about is Spring Native project. So that is an integration project between Spring Boot and native image that allows you to use native image as a platform to run Spring Boot applications. And what we are looking here at is their results from, I believe this is Spring 1 keynote last year. And this was still work in progress. So this project is still ongoing, but you can see what great results in terms of startup time and memory usage. So what are the results that they've accomplished by moving to native image as the platform? And to illustrate that thought a bit more, so this is Spring Native applications running, on Spring Native, right, as opposed to running on a JVM. And if we are looking, for example, at the container image size, we also can see how much smaller it is comparing to the JVM. And another great way to use native image and another great project that is leveraging native image is Jhipster, which is a project that allows you to easily build and bootstrap web applications and microservices. And it also now has this integration with native image that you can leverage by using Jhipster native as your blueprint. And here you can see how my application starts in something like, well, under a second, right? But I think it can start even faster on a better machine. So that is another way to easily build applications that are ready to go, and they are also very fast thanks to native image. Now, how do you make even more out of native image, right? So maybe if you want to use it in production or use it for your pet project, you want to make sure that you are making the absolute most out of it. And there are a few things that you can do. So one is you could be probably thinking at this point, so what about peak performance, right? So if we are building and compiling the application at the image build time, what about peak performance? So how do we optimize for it, not having that runtime profiling information? And that is a very good question. And the way to approach that would be, we have something called profile-guided optimizations. And what you can do is you can run the application first, collect profile information about it, and then feed that profile information to native image at the image build time. So the application can be built and compiled with profiling information in mind, so aware of the runtime behavior of your application. So it can be very, very fast when you run it because we already have and use that profile information. So I will get to that in a second, but just to give you a few more ideas about native image and what you can do to optimize for peak performance with it. There are also some memory management options available for you in native image. So by default, you get 0GC, but also we are working on advancing it in, for example, improving policies that 0GC is using in native image. But if you want to get more options, there is also Jvmci available in native image, or you can use Epsilon GC if you don't want basically to do any GCs at all. And a few more things that you can do with native image. If you would like to monitor performance of native image, we have integration with JFR, so you can use JFR to monitor and optimize performance of your native image. For that, you would just need to pass specific flag when you're building your native image, and then you can enable it and start a recording when you're running it. And then you can use something like GraalVM to observe and analyze performance of your native image application. And if you want to kind of keep reading and learning about native image, there is this article we published recently on InfoQ, where you can get a few more details about it. And in fact, there are follow-up articles from other teams in the ecosystem talking about how they leverage native image and what are the things they've learned from using it in production. So if you want some additional resources about native image, I do recommend this series at InfoQ or checking our website, graalvm.org. Okay, let me just quickly check how we are doing on time. Okay, I probably would need to speed up a bit. So what's new in native image? A couple of things that I'm very excited and that I want to share with you is that we are working hard on improving developer experience for you. And one thing we introduced in the last release in 20.1 is this quick build mode. So if you are just developing your application, you probably want to get results first, right? So build application first. And for that, we have this quick build mode. So by passing this flag, you can speed up build time significantly for development purposes, but then you would want to use normal default compilation mode for running in production because it's way better optimized for peak performance. But if you are still developing applications, right, so for development purposes, this quick build mode is great because you can get, well, your builds to be much, much faster. And on top of that, we are also speeding up the default build times. So we know that many people care about this, right? Because you want your application to build faster, to get faster results, to move faster in your development process. So we are working on that as well. And to make the image build process even more helpful for you, right, to give you more insights into what's happening, we have this new build output that shows you exactly what is happening, shows you some information about GC and memory usage. And yes, this is very helpful if you would like to understand better what is happening during the image build process. And if you're using GitHub Actions for your workflows, we also have a GitHub Action for GraalVM, so you can easily use it in your GitHub Action workflows. And as of last release, we also have Apple M1 builds, and this seems to be a very exciting update for the community. So a lot of people are excited about it. And in fact, community helped us a lot to work on this feature. So yeah, if you are a happy M1 owner, you can now use GraalVM on it as well. Now, very quickly about Polyglot capabilities of GraalVM. So I said that we support all those languages, and we also support interop between them, right? So it's fairly easy if you have your main application written in Java, add some code from, let's say, JavaScript or Python to it. And the best part is that GraalVM will not only give you a platform to do so, but it will also give you tools to work with such a Polyglot application, and it will optimize the whole thing for you as well. So yeah, we have a JavaScript engine, for example, and what you can do with it is that a really great use case for it is that when you want to do, for example, server-side rendering of things like React.js, you can use GraalVM as basically your main runtime, right? And if you have, for example, Java application, and then you have some React on front end, and if you want to do server-side rendering of it, GraalVM really gives you the possibility to do so because it supports both of those languages. And in fact, it supports even more, so you can use any number of supported languages in your application. So this is an interesting project of one of my colleagues from early days of COVID, where he wanted to visualize trends of how many cases are being discovered in his country. And he built that application using Java, JavaScript, Python, and used R to visualize the actual trends. So basically, you can use tools and libraries from each language to literally use the best of them and make that happen in one application. And this is an example of using Python from GraalVM. So yeah, if you want to build something like this is a recommendation system, right? So probably you want to use some libraries, let's say from Python, because there are plenty. And this is an example of Oracle NetSuite using Python libraries in their Java application and running all of it on GraalVM. And to give you an idea of what else is possible with GraalVM, so in the very beginning, I was talking about this JIT mode, right, where you can run applications with GraalVM as a compiler, and that is something that Facebook did. And the reason to do so is because they saw performance improvements of around 10%, and specifically also in terms of CPU usage, just by switching to GraalVM as their JDK. And this is an example of somebody using native image in production. So Alibaba moved their applications to native image as a platform. And here on the left, you can see that they got 20x faster compared to running on a hotspot VM. So those were massive and massive applications. But yeah, this is the kind of speed up you can get with native image. And to get started with GraalVM, so if you're wondering about our releases and release roadmap, we have 4 feature releases a year. And you can get this information about which release is coming up and what is planned on our website, that is graalvm.org. And yeah, this is where you get started, where you can get downloads. And yeah, so you can use GraalVM Community Edition, Enterprise Edition. You can download it, you can use, for example, on Oracle Cloud. Yep, so to get started, please go to graalvm.org and you can get downloads there. If you want to follow updates, we are very active on Twitter. And if you want to ask questions, we have this amazing community on Slack, or you could write us an email if that is your preference. I think that's all that I had for today. And I think I'm almost perfectly on time. So yeah, I think that's all from me. Thank you all for being here.
I feel like a kid in a candy store. I
Oh.
have so much to learn and do and love now. I've been a Java developer since 1998, but now I feel like I've just rekindled my love. There is so much incredible innovation on Java with GraalVM, and it makes developers' life easier and happier, and the velocity is increased.